So historically, the BTK inhibitors that we have been utilizing for relapsed refractory indolent B-cell lymphoma has been mainly represented by Ibrutinib. Ibrutinib is not a very BTK-specific inhibitor, has a lot of off-target activity, for example, on ITK, or some kinases in tumor-associated macrophages, such as LIN or SRC. What we saw with acalabrutinib is that while similarly to ibrutinib in follicular lymphoma, it's able to interrupt the crosstalk between the follicular lymphoma clone to the B-cell receptor and tumor-associated macrophages to a receptor called DC sign, and overall downregulates pathways of survival in the follicular lymphoma clone. But limitation is that due to the lack of specificity, ibrutinib also negatively impacts the anti-tumoral activity of tumor-associated macrophages. Differently from ibrutinib, second-generation BTK inhibitors such as acalabrutinib or zanubrutinib, and now more recently also non-covalent BTK inhibitors such as pirtobrutinib, being more specific to BTK, they do still interrupt the crosstalk and so have a favorable effect in terms of repolarization of tumor-associated macrophages, but they do maintain a more anti-tumoral phenotype in the latter. So, you may argue that more specific BTK inhibitors may not have a direct impact on T cells, as usually the benefit is ITK mediated, but there may be an indirect benefit due to indirect effect on the tumoral clone. We are trying to understand how this can be now integrated in the treatment algorithm for indolent B-cell lymphoma. I want to remind currently there's a BTK inhibitors approved by the FDA for relapsed refractory follicular lymphoma in third line and beyond, and it's zanubrutinib, so a second-generation BTK inhibitor in combination with obinutuzumab. But we hope that our data will also change the paradigm that BTK inhibitors cannot be utilized in indolent B-cell lymphoma and potentially move BTK inhibitors to the frontline setting to enhance the activity of immunotherapy.